This is, I have no idea what question this is. It's question number 90. It says graph the system of inequalities to the right on graph paper. So I've got a kind of a grid set up here. The one place where I see students make 2, 3, 4, 5, where I see them make errors is uh, this idea of squaring a number. And I know it seems kind of simple, but um, let's take for example. Okay, I'm going to pick some x values. So I'll pick x is you know, negative 1, 0, 1, just to start with. Now, if x is equal to 1, that means I'm right here at this point, right? X is 1. I've gone over 1 unit. And to find y, I'm going to square that, right? So I take x and I square it, and 1 squared is equal to 1. So this is a point that's on this curve. Um, it's on the boundary line, y is equal to x squared. If I take 0 and I square it, I get 0. 0 times 0 is 0. So this is a point on the boundary curve. Now here's where I see students making errors. They'll take this value, negative 1, and they'll take negative 1, and they'll write exactly this, perhaps in a calculator, negative 1 squared. Now, what that means, right, that means the opposite of 1 squared. And it's very subtle, but the opposite of 1 squared equals exactly negative 1. And that's not what we've got, because we're supposed to take x in its entirety. We're supposed to take x and square that. So negative 1 squared is equivalent to negative 1 times negative 1. So what we're looking at here, negative 1 squared equals positive 1. So on the other end of this, right, we've got the, right here, this is going to be a positive 1. Now I'm going to extend this for a few more. Let's look at 2 and 3. And then let's look at negative 2 and negative 3. So if I square the number 2, I'm at 4. That makes sense right there. And if I square the number 3, I'm at 9. So this one goes way up here to 9. Okay. If I square negative 2, I hope we understand that means negative 2 times negative 2. So negative 2 squared is positive 4. And negative 3 squared is positive 9, right here. So what I'm looking at is this parabola, right? And in fact, it's the father of all parabolas, right? And it is a dashed boundary line because it was y's are less than this curve. So let me continue on this side. And I am, going to shade, just kind of preliminary. I'm not going to shade the whole thing in, but I'm just going to tell myself, hey, it's everything below this curve, below the curve, below the curve. The other one is a line, right? It says y is greater than or equal to x plus 2. And if I think about that, in terms of y equals mx plus b, I can see that my y-intercept is 2. This is crossing the y-axis at the point 2. And then it has a slope of 1, up 1, over 1, up 1, over 1, up 1, over 1. And we can continue this both directions, right? Those are all these lines, and then down 1, back 1, going this way. This particular boundary line is solid because it says y is greater than or equal to x plus 2. So here's the line y equals x plus 2. That's the line. And this inequality says y's are those things that are greater than that. So I'm shading above this curve, above it, above it, above it. And what I see is there's this specific region right here, right below the parabola and above the line, and that continues on like that. And then also here, there's this region here, right, above the curve and yet below the parabola. So the solution is any point that lies in that shaded region.